Hello and welcome back to Math 8. This is a video over section 6, and what we're going to be doing is we're going to be making predictions, okay? So we're going to first use a calculator to graph a scatter plot and create lines of best fit, and we are going to substitute x and y values into the data to create predictions of real-world scenarios. And then we're going to analyze data to determine interpolations and extrapolations, all right? So we use these scatter plots and lines of best fit to make predictions about what's going to happen in the future. So we can follow these patterns, draw trend lines, and then make predictions based off of that, okay? So interpolating data graphically means that a prediction is made within the range of values in a data set. So interpolating means that I'm going to look at the graph here, and I can just answer questions based off of this graph, okay? So what I want to do is I want to use the graph to predict the income of a teacher with 3 years of experience, okay? And so what I'm going to do, here's my graph where I've got, let me zoom in a little bit, where I've got my years of experience, okay? And I have the income in thousands of dollars. So as teachers work, they get paid more, okay? I have that exact same thing. Every year, I usually get paid a little bit more money. It's pretty sweet. Anywho, we want to find out, okay, when x is 3, when we have 3 years of experience, then y is equal to what, okay? And so we look at our graph, okay? And I'm going to look at our trend line. And here's 3 years of experience. And here's the value that I have on this graph, all right? And then I'm going to color that in blue because it's not exactly where that other point is. And so I'm using the trend line to actually answer this question, okay? I'm not using the points on the scatter plot, but I'm using that because this allows me to say, all right, here's what, I can say about, this amount of experience, okay? And just kind of make a general statement about that, all right? So 3 years of teaching experience. This is probably about, it's a little bit, here's 30, here's 40, 35 is in the middle. And it's just a little bit above 35. So what I could say is that we have a Y value of about $36,000. Okay? And that's my prediction about how much. Now, if you said, maybe 37, maybe, that would fit, but it definitely wouldn't be 35. Okay, you could either get away with 36 or 37, or you could say 36,500. Okay, and because we don't have, the equation of this line, all right, and we don't know, necessarily exact numbers on this line, that's the best that we can do. Okay, and that's what we've got. Okay, so on this part, this next question, it says use the regression equation to predict the life expectancy for 1981. So we have the scatter plot where we have time in years and then we have age in years, and this is the life expectancy, okay? So what we want to do is we want to figure out, what the life expectancy is for the year 1981. Okay, so here's 1980, here's 1990. Okay, we can kind of guess and estimate what that would be. It might look like it's about 74, but maybe not. So what I want to do is actually plug 1981 into this equation for x to get y. Okay, so x is years, time in years, and the y value is age. So to get my life expectancy, I got to plug in 1981 for x. So let's do that. So x here is equal to 1981. All right, we're going to plug that in. So I got y equals 0.156 times 1981, and then minus 235. So if I take 1981 times 0.156, that's going to give me a value, so y equals, this is going to be 309.036. And then I'm going to subtract off 235 from that, so minus 235, and that's going to give me that y equals 74.03. 0.036. So we can just go ahead and then say, so it looks like it's a little bit more than 74. So y equals 74 years. Let's go ahead and round to the nearest year on that, because of 0.036 isn't very much, bigger than 74. Okay, and let's do the same thing down here. Okay, so we want to use the regression equation to predict the year when U.S. life expectancy was 76.5. So same thing, okay? We're using the same equation, all right, same scatter plot, but what we're doing is we're talking about predicting the year when the life expectancy was 76.5. So here's 76. Okay, it looks like it's going to be, in the 90s at some point. All right, so what I'm going to do is plug this in for y. So my y value here is 76.5, okay? And we want to figure out what's the x value, okay? So I'm going to use my equation down here and plug in my value. So I've got 76.5 is equal to 0.156 x minus 235. So let me add 235 to both sides. Okay, those are going to cancel out. So I've got 76.5 plus 235. And that's going to give me 311.5. And that's going to equal 0.156x. Divide by 0.156. Divide by 0.156. So divide this by 0.156. And that's going to give us an x value of 1996.8. All right, so we'll just go ahead and round that to x equals 1997, round to the nearest year. And that's when the life expectancy goes up, okay, to 76.5. So that's what we've got. All right, so now the next thing we're going to talk about is extrapolating data, okay? And what we're going to do is we're going to do the same thing, but when we talk about extrapolating data, is a prediction that's made outside of the range of values in the data set. So currently what we're dealing with is, we're going from like 1975 to 2010, okay? And what we want to do, and same thing with like age. Age goes from like 70 to like 80, okay, up here. So we want to predict the year when U.S. life expectancy will be 90 years. So what we're going to do is that's outside of our range. But we can use this same trend line because it seems as though the trend is going up. And this trend line is a really good fit of the data. So this is a pretty good predictor of what we can do if the life expectancy is 90 years. So let's do that. Let's plug in y equals 90. And we want to solve for x. Okay, so same thing we did in the last one, except for extrapolating means that we're talking about something that's way outside. So I don't have a number here. I don't have 90 on my y-axis to kind of gauge, hey, when's this going to happen? All right. In both of these top previous problems, I was able to look at the graph and make at least a guess as to what we were supposed to do. All right. So let's go ahead and talk about that. So extrapolating data. All right, I'm going to plug 90 into this equation and solve for x. So I've got 90 is equal to 0.156x minus 235. Okay, I'm going to solve for x. So I'm going to add 235 to both sides. So 90 plus 235, so 90 plus 235 is 325, and that's equal to 0.156x. I'm going to divide both sides by 1.156. Divide by 0.156. 0.156. And this gives us a year of 20,083. Whoa. So by that point, the average person will be living to 90 years old based on this model. Now, that's just a prediction. Is this true factual information? No, it is not. But it is a prediction, okay, nonetheless. So if things don't change and we just continue to, have the resources available, then by 2083, life expectancy should be about, 90 years. So pretty cool. All right, that's all I got for this lesson. Hopefully you enjoyed it, and we'll see you in a bit. Thanks a lot. Bye.